Welcome to the latest Trees Around the Globe Student Research Campaign webinar, The State of Trees Under Snow, Part 2. I should say this is near and dear to Peder Nelson's heart. March 2025, featuring results from the February 2025 Snowview Intensive Observation Period with a focus on snow and ice land cover observations. So thank you all for being here. And those of you who are watching the recording, thank you for watching that recording, as I know a lot of you do that individually, and actually have some folks talk about it, how they watch a lot of these in their classroom. So thank you for that as well. First off, I wanted to celebrate, and my friend and colleague, Valerie Casasantos here. Valerie is the Outreach and Communications Lead for the NASA Ice Cloud and Land Elevation Satellite 2, or ICET-2 mission. She's at the Goddard Space Flight Center in Greenbelt, Maryland. As you know, I'm at the NASA Wallace Flight Facility in Wallops, Virginia. Goddard Space Flight Center is the larger center, and Wallops, where I am, is a field office of Goddard Space Flight Center. It's about 3 hours away. They're about 3 hours away from each other. But last Sunday on the 9th of March, was it the 9th? 9th, no. Yeah, on the 9th of March, I believe it was, that the ICET-2 satellite, or the ATLAS instrument, the Advanced Topographic Laser Altimeter System, fired its 2 trillionth laser shot. So that's just a mind-blowing number. You can see that's 2 trillion right there. And you know what you have here is, you can see here, this is the shot where it's located. And this is what you see, this purple right here on the bottom left above the word blog and the URL. That is just off of Antarctica, okay? So this 2 trillion shot from ICET-2 is this green vertical line. And you can see here, the first thing that this hit after it left the satellite was it hit some clouds in the atmosphere. Okay, so we saw some clouds. You can see the little map here on the top left where that 2 trillion shot was. And right here is the actual shot that came through, and you saw that it hit the clouds in the first spot. Valerie, I don't want to put you on the spot, but is there anything you'd like to say about this? And I'll put that blog, that URL in the chat then, so you can take a look at the blog that was written by Kate Ramsayer. She is a science writer and with our ICET-2 outreach team at Goddard Space Flight Center.
Yeah, thanks, Brian. Well, it was really cool to reach our 2 trillionth shot. And what's really cool about it is that sometimes clouds get in the way, right? And for our mission, usually they're in the way, but there are people looking at the cloud properties with ICET-2's laser shots. So we're able to see, what type of clouds they are, if they bounce off the top surface or if they penetrate through. And in this case, we did get a few openings to the ocean floor, not the ocean floor, sorry, the surface of the ocean through some of the clouds. Even though there was cloud cover, we had a couple openings so we can see the ocean surface there. And also, as Brian mentioned, it went over, I think, the Andes Mountains as well, and came over the ocean and then went across Antarctica. So with that one pass, we passed over a lot of really different areas that ICET-2 can measure, including land surfaces, tree heights. Maybe we can go back and look at that to see if we actually got any trees in that pass. This could actually be a really cool project for students to do, to look at that individual pass, either this one or another one, and see all the different areas it goes over the Earth. And we will be doing a ArcGIS story map on this, so we will kind of go through the different areas that ICET-2 passed over and see what kind of measurements we got and what kind of science we can learn from it. So stay tuned for that. Brian and I will be working on that, and he'll let you know when it's ready.
All right, thank you, Valerie. And if you haven't already, Valerie, can you put the link to the blog from Kate in the chat? You like? I just have it down here as the bit.ly, so it's a shortened version, but feel free to just pop it in the chat. That'd be great, so people can take a look at that. There's some really good different images in there from one one of our team leads, Dr. Tony Martino. He's one of the ones who got us all this information. Where this trillion shot is. He's the quick brains behind the operation to try to figure out where all this stuff hit, where this hit. So congratulations once again to the ICESat 2 mission. And Valerie mentioned, we and as ICESat 2 is big part of this campaign because it's able to measure the height of trees on Earth from space. So, and this campaign was started, okay, just at the same time ICESat 2 was launched into space on September 15th, 2018. And one thing I like to mention is something that we calculated. It's a fun fact. I calculated that, if you were to act like a satellite and press a laser pointer, press the button, basically firing the laser one time every second, in order to get to press that button 2 trillion times, that would take you 63,000 years in order to do that. So that tells you just how big 2 trillion is. And ICESat 2 was able to accomplish that in just about 6.5 years. So definitely a technological feat there, just a marvel in the sky. So that's ICESat 2. So, all right. So we're gonna, talk about ice, snow, all that stuff. So today we're going to talk a little bit more about snow. But I like to show this here. These pictures, I'm also going to mention that these snowflake pictures, my wife's a professional photographer, so I wanted to show this, even though we're talking about ice and snow. And I mentioned it last time, and Peter talked a little bit about, the importance of snowflakes and things like that. But I wanted to just showcase this because there's a guy, a famous photographer from the 1800s and the early 1900s. His name was Wilson Bentley, also known as Wilson Snowflake Bentley. He was a photographer that was, probably the first photographer to ever get the insanely intricate details of snowflakes under a microscope. And here's this quote that I like by him. Under the microscope, I found that snowflakes were miracles of beauty, and it seemed a shame that this beauty should not be seen and appreciated by others. Every crystal was a masterpiece of design, and no one design was ever repeated. When a snowflake melted, that design was lost forever. Forever lost. Just that much beauty was gone without leaving any record behind. And this was an inspiration for my wife. We toured up in Vermont. We toured the Snowflake Bentley Museum, and she started doing a lot of snowflake pictures, when she heard about this and, figuring out with the photography how she could do it. So all these pictures here are ones that she's taken. These are just from, most of these are taken just about a month and a half ago during a snowstorm. And the surface that you're seeing these on are T-shirts. They look like sweaters, but they're not. These are actually T-shirts zoomed in with a macro lens. And then she holds what's called an ice light up to give that snowflake the reflective surface so you can see it better on the matrix of that T-shirt. So I just wanted to showcase this. So it's a nice way to get us thinking about, the cold topic we're going to focus on today in continuation from last month's webinar. So, okay, so here's the agenda. I won't go through everything, but we're going to be featuring with Peder Nelson some results from the February 2025 SnowView IOP. And then we have some examples that I'm going to lead into before I pass it over to Peter then. But then also just going to want to bring up what's we just had the SnowView IOP in February, and right now in March, you all probably know Dr. Kevin Chakowski at the University of Toledo. He is also a Globe partner, works with OhioView. But right now, as you know, for a while, he has been running the Urban Heat Island Effect Surface Temperature IOP. It was before, I think it was called the Surface Temperature Field Campaign. It's an IOP, but during March of 2025, which we're in the middle of right now, he is running one where he's looking for data from anywhere, any surface temperature data from around the globe community, basically looking at urban heat island effects. And I have a website here that will take you to that campaign as well. So we'll showcase that in a little bit. And then we're going to end with just a reminder, if you haven't completed the Trees Around the Globe Student Research Campaign survey, the one that Matt was here last month and he introduced, and a lot of you did do it. So thank you for that. But there are some folks that we'd like to still get it from. All right. So Couple metrics here, like we always do. There's our participant countries for trees around the globe. And then the observations here that I like to show, especially the ones at the bottom. We have over 227,000 observations from almost 70,000 global sites as of this morning, for the campaign, for the length of the campaign since the 15th of September 2018. And then I'd like to draw your attention down to year 7. We are going, fast and furious here. We're at almost 10,000 tree height measurements, just over 4,000 land cover measurements. And a lot of those are from the Snowview IOP, which was great. And then also we have about 5,600 green up, green down, or greening observations. So we are getting these numbers up pretty quickly. They're jumping up. So, thank you for that. And that's, as it says on this slide, that's a lot of data to look at just over this, just about 6.5 years of observations. Now, what I'm going to do is I'm just going to showcase this, and then towards the end, if we have time at the end, I'll take you to that blog. But a couple things here. I wrote a blog, so basically the leads for the science leads for the Globe Observer for trees, land cover, mosquito habitats, and clouds, and sometimes eclipse pops up. We do kind of a quarterly blog post on Globe Observer, and then we follow it up the next month with a Globe Observer Connect event, and some of you may have participated in that. But the most recent blog that came out this month in March was one I wrote, Globe Observer Trees Just Got Better. And the focus is the newly added way that you can enter the genus and species and or common names of the trees of which you're measuring the height of. So if you know them when you're looking at them, you'll have a drop down list. You can start typing into the genus box, and then names will start coming up. You can see here on the right hand the Latin name. If you don't know it, okay, our app won't tell you what it is, but we recommend, and you'll see this on the blog, that there are other great apps out there like iNaturalist or Seek by iNaturalist and TreeSnap. These are 3 really good species identification apps where you basically point it at the tree and then it will tell you what this tree is, and they're highly accurate. Okay, so this is some of the recommendations that I have in the blog for you. So happening in 2 days at noon p.m. Eastern time, basically 1600 UTC, we will have a Globe Observer Connect event for March of 2025. And it's going to start off with me just about talking 5 minutes about, like I just told you, about the blog. And then it's open for the next 20-25 minutes for an informal discussion for any of the participants to ask me questions, ask anybody else on the team questions, because we'll have folks on there from the Globe Observer team like Holly Cole and Kristen Weaver and other folks who are part of the Globe program as well, and Globe Observer, to answer any questions you may have. So this is going to be Thursday at noon Eastern time, 1600 UTC. So I will put this link to this after I'm done sharing. But I just want to showcase this with you, and hopefully you can sign up for it. At this link, you can register for it, and it's a really quick registration, basically your name and your email, and that's about it. And then you'll get an email with the I believe it's a Zoom info, like you're on now. You get a Zoom info invite, and then you can pop it in your calendar and join us on Thursday. All right, so this is as of this morning, so it's not 100% final. The date is pretty. The date is good because, and I don't know if Anna's on right now, but I've been going back and forth with Ana Prieto out of Argentina, and we're going to focus a major part of our April 2025 campaign webinar on a collaborative research project that Ana Prieto and the students from Argentina did with students in Texas in the United States, where it's trees and their impact on carbon storage and surface temperature, a comparative study of trees in Argentina and the United States. So this is, 95% certain it's going to happen on Tuesday, the 29th of April at 1 p.m. Eastern time. Okay, 1700 UTC, 1800 Central European time. So mark your calendars for that. You will get an invite once I get that confirmed. You will see the invite like I always send out. So just, pencil that in on your calendars for our next campaign webinar. We're trying not to do it the week of Earth Day, which is the 22nd of April, because there's a lot going on in person and virtually during that time. So it's a really, really busy time during that week. So we're going to do it the week after. And this gives Anna and the folks in Texas as well to some time to prepare. All right, so the submission period has ended for the IVSS 2025, 30 years of Globe, understanding the past, present, and future. And next up on the agenda is going to be the judging of the projects. And I got notification with a meeting yesterday that there are over, I think there are over 400 research projects from over, I think it was 35 Globe countries. So that is great to hear. Sounds like another record-breaking number for research projects. So super excited about that. So we are going to be, there's going to be folks going to be judging these in the near future. So, and then you can see here, the judging period is actually, I guess it starts tomorrow through April 2nd, and then Earth Day celebration on the 22nd of April, and announcement of stipend recipients. So stay tuned for that. You can always go to this website that's listed below, and this will give you that calendar as well, and you can learn anything about that. All right, so now we're going to get into the topic of discussion today, and that's going to be snow view, globe photos of snow in clouds, trees, and on land. All right, great. So now I'm just going to show some examples here, and Peder Nelson, please interject if you'd like to say anything about these. But what I wanted to do during the February 2025 Snow View IOP is we had a couple snowstorms here in Virginia and Maryland, and you can see here this is some comparisons that I did on the 11th of February, where I was actually in my office. We were told to get out by noon at that time, but I didn't. I was stubborn because I wanted to get some good snow pictures and everything outside. I know Peter will appreciate that, but I basically was one of the last people on center, and it was usually takes about 55 minutes to drive home, and it took almost 3 hours to drive home because the snow is so bad. So I kind of regretted that. But you can see here on the 11th of February at about 2:30 in the afternoon, this is what it looked like, all the different directions. You can see the snow was coming down pretty good. And then we had some like unseasonably warm weather over the next day. And you can see here 2 days later, every bit of that snow was gone. And that was just in 2 days. I was from February 11th at 2:30 p.m. And then it was on the 13th of February at 8:30 a.m. So you can see everything was gone in that amount of time. And this was at the NASA Wallace Flight Facility. Then also, when I got home later that day, okay, I went and did some observations. That should be actually, sorry, that should be 15. But I did some observations in an area, well, I should say on the way home towards Salisbury, and I got some really good snow observations for land cover as well. And I did some tree height observations too. And you can see this was 3 days apart. So I didn't get back out to that same spot until 3 days later. But you can see there is no snow left to be found. So there was a really quick snowstorm. We got a lot of pretty good amount of snow, as you can see. And then, within 2 or 3 days, it was completely gone because the temperatures went up pretty warm and everything started melting again. We got a little bit of rain as well. But I wanted to show you this as a kind of a way to lead into what Peter is going to talk about a little later today. Now, I know, John Moore, you are on, correct?
He's on, Brian. He's just muted.
Yep.
Okay.
I'm here.
Hey, John Moore. Thanks for being here. But I wanted to put these slides up because John shared these with us, and this is he did these. John, I should say, John is you probably all know John. He is the director of the Palmyra Cove Nature Park at the Institute for Earth Observations in Palmyra Cove, New Jersey, and he did these as part of the February 2025 Snow View intensive observation period. And John, are you okay if I play this little video that you sent us?
Sure, go ahead.
All right, here we go. And then after it's over, I'll let you, if you want to say anything about like some of the images that we have here, and you know, some things you experienced. But I think you tell it well in the video. Here we go.
Hello from southern New Jersey. This is John Moore reporting for Snow Cover. It's not sunny out, but I'm wearing my sunglasses since Peter set the trend for globe scientists. But here we are, snowstorm last night. We're South Jersey, about 7 miles north of downtown Philadelphia, and about 50 miles from the coast. So we have about 3 inches of snow here in this part of New Jersey. The snow varies a lot. It's actually hard to forecast because 60 miles to the east is the Atlantic Ocean, and 60 miles to the west are the Pocono Mountains. So the forecasters here have a rough job of doing ocean forecast, marine forecasts, air forecasts, and then everything in between from the shore to the Poconos. And this was one of those types of storms that came across from the south. So actually down the shore, which is usually warmer, had more snow. They had 6 to 8 inches in like Atlantic City and Ocean City. Just the difference between here at the Cove versus where I live is probably an inch. So we had about 3 inches of snow here. And so I just wanted to report that. And since we're so close to Philadelphia, I consider ourselves, we're the antidote for Dr. C's urban heat island. That's right down the river there a little bit. So we have the trees and the forest to add to cooling. Okay, carry on, everybody.
All right, thanks, John. Yeah, that's great because we just mentioned the urban heat island effect and the surface temperature IOP. So I forgot that you mentioned that in that video. Anything else you want to say about about your examples that you showcased here, John?
No, just to comment that this is the same storm that you were talking about, Brian, down in at your place when you left. So this came up the coast. We're probably about, I don't know, what do you think, 120 or 50 miles north of
Yeah.
there. And so this was that storm, a little less than what you guys received. That's normal. That's it.
Excellent. Thank you, John. And thank you for sharing all the details and creating that video for us. That's great. It goes into the archives. And I know Peder Nelson is happy to see all this because as you might have heard a couple times, you know, this is like Peter's dream to do, you know, these type of observations and, you know, analyze these and make sense of these in the real world. All right. So with that said, oh, sorry. I have one more thing I want to show you before I pass it over to Peter, if that's okay. This is a cool video. Since we're talking snow, NASA Goddard Space Flight Center and has a scientific visualization studio, SVS, that a lot of you have probably used, and we've showcased a lot of videos from them. They have great video producers and content creators using the NASA science and data from satellites and instruments. So, and basically their objective is to visually make that science make sense in the real world. And this is a great one because since we're talking about snow, this is a NASA Explorer's Cryosphere, the snow below. And it will feature some cryospheric scientists and some you know, modelers who look at the science, look at the satellite data, look at the data on the ground, and they, you know, interpret it to make it make sense in the real world. So I wanted to show you this. It's a couple of minutes long. It's about 5 minutes long, but I want to show you this because this, I think, is a great video to show because it helps us kind of set that stage for the importance of why there was the February 2025 snow view intensive observation period, and why, you know, Peter and his team and the people that he's working with, his colleagues in Alaska and other places, have invested so much in this because just the snow cover as land cover can tell us so much. So let me play this here.
What we think of snow depends a lot on where it falls. If you live in the eastern US, maybe it's fun. Or maybe it's just a pain.
But if you live in parts of the world where they depend on the water that's in the snow for a large fraction of their total water that They use for drinking, for agriculture, for industry, or for hydropower. The snow is a very important natural resource. For example, in the western part of the United States, 80 to 90% of their renewable water comes from snow.
Snow is one part of the cryosphere that many of us have actually encountered before, but it also plays a critical role in regulating the Earth's climate. Through decades of remote sensing, NASA has kept a close eye on the ebb and flow of snow cover.
We now have a 52-year record of snow cover in the Northern Hemisphere, and we can see changes in the extent of snow cover over the time period, particularly in the last few decades, where we can see that the snow cover has been retreating. It's been melting a lot earlier in the springtime.
The extent is relatively easy to do, and it has been done over the years. What's tricky is, though, how thick is that snow? And it's even trickier how much water is in that snow.
That tricky part is known as the snow-water equivalent, or how much water would actually be in a layer of snow if it melted. NASA and its partners have taken to the air to help solve this elusive mystery. First, there's the Airborne Snow Observatory, or ASO, a small plane outfitted with a couple of instruments, one of which measures snow depth using LiDAR. LiDAR measures distance using light from lasers. Since 2014, ASO has flown over basins in California and Colorado, taking before and after looks at snow depth. Scientists subtract the snow-free summer data from the snow-on winter data to get an idea of the snow depth. There's no single way to measure all types of snow across the globe, and so NASA's other airborne campaign, SnowX, is testing different combinations of sensors. This winter, SnowX will test a new instrument, the Snow-Water Equivalent Synthetic Aperture Radar and Radiometer, or SWISAR.
SWISAR consists of two main components, one of them being the radar and the second one being the radiometer.
So with the radar providing the depth of the snow and the radiometer providing the density of the snow, we could put those two things together and get the snow water equivalent. Here in the chamber, we're going to measure different radiation patterns that are different frequencies and do some full system testing in this chamber. This chamber kind of enables us to isolate various types of radiation and interference. And in about a month, we're going to take the instrument, mount it on a Twin Otter in the Grand Mesa in Colorado. We're going to fly it over the Grand Mesa and take various different measurements. This is what we call our engineering flight.
Making sure the sensors are calibrated is key in order to face the challenges nature will throw at them.
Half of the area that gets covered by snow every winter contains trees and forest. And the trees make it difficult for the sensors to see the snow that's underneath the trees. So it makes it difficult for us to measure how much snow there is. After the snow's had a chance to sit on the ground for a while, it gets denser and denser and denser over time, and it changes, which is another reason why snow is very challenging to remotely sense. It doesn't stay the same. It's constantly changing. One of the things that we often do in the field is go dig what we call a snow pit. We literally dig a pit in the snow so we can see all the different layers. The layering is very important.
All this digging is part of ground truthing SnowX, a way of matching up what the airborne instruments see and what is actually sitting on the surface. The ultimate goal of SnowX is to figure out what the best combination of instruments would be for a future satellite mission in order to get a global picture of snow.
We need to know how much snow is in a snowpack, because if we had too much snow and the snow melts too fast, then you can get flooding. And if you don't have enough snow, or if the snow melts too early, that can lead to a longer wildfire season, a more intense drought. And we need to know these things for water resource planning.
All right, so I hope you learned a little bit from that. It really showcases, the importance of snow. Just one example with the SnowX mission, the airborne campaign that, measures this as well. So just wanted to bring that to your attention, and you can check out lots of cool cryospheric things on the Scientific Visualization Studio. But I'll throw all these links in the chat in a bit. So Without further ado, I'm going to pass it over to Peder Nelson, and he's going to talk more about the February 2025 Snowview IOP. Peder, let me pass it over to you.
Hey, thanks, Brian. And Tracy, I really appreciate your background that you decided to put up for us. I haven't changed mine in a little while. It's still summer where I'm hanging out, which is in New York, actually. So I appreciate the variability that our community comes with, and that just makes me smile so much, very much. And so I wanted to start off here, picking up where Brian left off, which is how important our ground measurements are, because those scientists were highlighting how often and quickly snow changes. So this is a fundamental challenge. It's easy to see that snow, but it's also a little bit more challenging to figure out, again, how long is it going to be there? And it looks like my Zoom is updating and slowing down, so I'm a little frozen, but I want to flip here and go to why we're really concerned about this. And also, again, scientists have been doing this for a really long time, and trying to figure out what's snow, what's cloud. They're both bright, they're both cold, but they're at different altitudes, and they end up doing different things. One's on the land, one's in the sky, right? So snow cover is one of these variables that you can find out there. And one of the things that I want to bring up is how important it is to think about the spatial area that we're going to be describing here. Again, that's one reason why we have engineers still working on this problem, is because some of our data is really covering a large area, and there's a lot of variability that can happen in there. Sometimes there's trees. Again, sometimes those trees vanish on us, and all of a sudden we now have a darker landscape. And in some places, the topography, it can really change how much and where that snow is located, and kind of that brightness. And so again, depending on where you are, you care about this for different reasons. I'm just going to say that, for me, the first thing is just, it's a barrier. It prevents us from moving, as Brian was describing. It can make it challenging to, just get around in a community. And as the seasons change, as we change that orbit with the sun, the snow cover will change. And that's something that people take for granted. And only through our databases and our imagery can we really help people understand how this year is different from last year and the year before. So I want to emphasize here that there is a lot of data out there related to this topic. Explore it, find out what it looks like in your area. That is a really important task here, because again, the scientists were highlighting, we don't have enough information on the ground. And so we try to use whatever we have. And so you can find a lot of more tutorials out there with this. I'm going to, hop over and show a little bit of a distribution here, a map, also known as a graph, of where we had submissions from. And this, to me, hopefully starts to make a little bit of sense to you as well when we look at this map. In particular with what Brian showed us. We were expecting snow cover, in this case, the blue squares on the map. We would expect those to be in the Northern Hemisphere. Again, as Dorothy Hall was highlighting there, the Northern Hemisphere is where we've spent a lot of time mapping this. It's where most of the snow and ice occurs in the world, outside of Antarctica. And so this, to me, is a very expected result. The nice thing is, across the tropical areas, or some of these southern globe countries, we didn't see reports of snow cover. Again, that was matching the hypothesis that we've had and developed over time. But there's a couple things that I now need to investigate, because there's some things that are unexpected here, right? And I hope that you notice this too. You know, an example like this is we have a report here near Sao Paulo in Brazil during this time. Well, that may be right. It may not. I don't really know at this point. It's a hypothesis, right? Somebody is suggesting that we're seeing something here. And so I now need to go and investigate that data point a little bit more before I trust that this is an actual true observation of snow cover in this location. Partly because when I look around, everywhere else is reporting a red or no snow cover, right? So when I see an anomaly like this, that's an indicator that I want to go do a little bit more investigation. Same thing over here, where we tend to have a lot of problems, or where we see some interesting patterns in our data, in just our point data, when we put it onto a map. Again, you know, is it expected that we would have snow in the country of Nigeria, or in Lagos here, or out in the ocean, right? Luckily, with this graph and map, I actually have some context. I have land, or what I think is land here, that helps to guide me in this understanding of whether something is on land or whether it makes sense for that location. Again, when I look around and I see red dots and then I see blue dots in the same place, that's something I want to investigate a little bit further. And that's where the satellite data can really come in, right? Because we do know from prior globe expeditions that there are glaciers and snow in the tropical areas. There was a whole globe expedition to Mount Kilimanjaro. And that is one of those places that is in this tropical area of the world, and unexpectedly has snow cover, right? So just because because these reports are maybe unexpected, doesn't mean that they're untrue, right? We need to investigate them a little bit more. And so, you know, to me, this pattern makes a lot of sense. I mean, it was even really nice to see some examples down here coming in from Antarctica, primarily cloud observations, because those are a little easier to do for people, apparently. And, you know, but that up and down photo is something that we can use to corroborate whether this reporting in the South Pole area is quote unquote correct, or what they're suggesting is true. Again, you know, this makes a lot of sense. Here at 45 degrees latitude south in Argentina and Chile area, we're getting reports of no snow. Again, that's to be expected. We had Ana Prieto on here telling us, yeah, she's having students go out and collect other sort of data at this time. But knowing that there's no snow here is something that we'll be able to come back to and ask the question, is it always like that? And I'm bringing up this particular latitude of minus 45 degrees or 45 degrees south, in part because that is literally the other side of the globe from where I am currently sitting at 45 degrees north latitude. And so that is a nice way that we can actually do this comparison between our locations in the southern hemisphere and similar locations on the opposite side of the world, just further north, right? And here, if I zoom into this location that I'm going to talk about, which is 45 degrees north, right here, going between Portland, Oregon and Salem, Oregon, we see that there's, again, a bit of a mix where we have some red dots that show up indicating no snow. And then we have these areas where there is some snow reported. So it's not as clear of a signal as what we had in the southern hemisphere down in that part of the world. And that also makes sense. This is something that we reported, and I've done a lot of reporting on. In fact, again, if we zoom in, this particular map is telling us that there is some mountain range right here. There's mountains that actually help to create this reported snow cover. This is a typical thing that you might see if you have a base map that might tell you something about elevation. And so this was definitely a feature that we did on our snow views, is thinking about the elevation. So it's not just that latitude piece, how far away from the equator are we, but there's also this elevation aspect that comes in and can sometimes create conditions really perfect for snow to stick around. And that's what we have here in this location where there's just a lot of blue that was reported. In contrast, an area that I made some videos and reported on, which is closer to 0 degrees or 0 elevation, is down here, where we can see that there was a mix actually during this time of snow reported and no snow reported. Again, if you want to see some of this, we have that on our videos. But you know, this is something that you can start considering and start looking at. Are the surface conditions the same in your location, or are they actually changing in the way that Brian indicated and the way that John Moore indicated, where you might have actually had a snow event come through? And so, you know, that those snow events are one of those things that we're trying to track. Again, the timing of when this is occurring is as important as where it's occurring, right? So let's not forget that time dimension. It does make it a little bit more challenging for us, but here, that's where NASA really comes in handy. And I'm going to go over to Worldview now because it allows us to explore some of our the snow numbers and the measurements that were made during this time period. And here I'm just kind of I'm zoomed in on this particular location here, partly because I was exploring it earlier. It had some really interesting submissions during this time. But I'm going to zoom out because one of the things that you'll see is if you zoom in too close, you'll get these errors when you're looking at your map or your data on these websites. And part of that, it goes back to what I initially started with. The spatial size, what is the area that this map is trying to show you? And so here, I'm going to keep zooming out because we're only looking at a day. And so one of the things that happens is you have missing data sometimes. It gets covered up by clouds. And so you can actually see areas where it's completely black, could be either places where there's cloud cover and you don't actually have the ability to see through that cloud. And so that's again where our ground observations really come in because usually snowstorms, like Brian was showing in his photos, snowstorms are usually come with clouds to create the snow. And so a lot of times you might have to wait a day or two even to make a remote sensing measurement. And so here, you know, I just zoomed out, but we can see that there's a lot of black areas. And if we go back in time, we can see that we just have different movements going on. Again, part of our challenge is to figure out, well, why do we have the colors that we do? And importantly, as I keep going back, you know, in time here, we can see that this location that was highlighted is really black a lot of that time. If we zoom in closer here, which again, I really recommend because this is where you can start to see the details of the world, right? It looked like there wasn't a lot there, but as we zoom in, you can start to see the size of our measurement on the ground. And we can actually see that one of our layers here is showing us that there's 16% snow cover in this area. Again, we have an area, and we have how much of that area is covered by snow in this case, right? And most of us should be calling this a blurry pixel or blurry image, right? Because when you get to a certain point, you are, as it says, over zoomed. The resolution is not detailed enough. You can't really see the trees, like what's behind most of us when we're down in the world, right? That is one of our limitations from space, from an airplane, from those instruments that we're trying to use to actually measure this. So this is a good tool to look visually at some of these things, but recognize that there's a limitation to them. But it's a great way to just start going through and looking at, did we record any snow cover in this location where we had ground photos submitted? And I'll just go through that, we'll quickly move forward, because finally, February 17th, we get a clear observation. And I mean that because we actually have numbers, we have a pattern. It's not black anymore, right? So that to me tells me that we actually have a measurement. And when I look around here, we can see that one of our snow layers is telling us 46% of that area is covered in snow. We have a little bit of variability, but you can see that it's anywhere from 65 to 30% area is covered in snow. We go down here, and again, it's cloud covered, or we're not able to make a measurement. But again, here we're not having 100% cover, right? So that, I think, is an important number to notice, is that it's not 100% of that pixel or 100% of that area that is covered. And so that's where we really need to go and investigate, maybe why is that? What's going on? And what might be causing that lack of 100% cloud cover or snow cover? That is a hypothesis. Why isn't this 100% snow cover? What is happening? What might we actually be able to see if we turn off our layers and maybe get some different reference layers involved here, like some satellite data, right? And so, this is where you can go exploring and find other layers here. Or again, I'm going to go back to the globe database now, because this is one of our challenges that we have in our community and is an opportunity. Our globe database and the globe photos are isolated from what we were just looking at. So I have to know the coordinates, and I have to be able to go back and forth between these different maps. Okay, but I was able to get those coordinates that we were looking at, and I went to the globe database, and I found on February 9th this photo that shows me a little bit of why this area might not be 100% snow covered. Like we were seeing in that video, there's some tree cover here. There's some asphalt. There's some buildings, right? There's some things that might interfere with our measurement, even if this area was 100% covered in snow, similar to what Tracy has behind her. I'm going to pick on that one because it's a nice, what we would consider 100% snow cover. And the thing is, if I go back here, our database allows us to then look at other dates in that location. And so I was able to find on February 17th, here we have an area that is covered in cloud, right? So our satellites usually can't see through. But even if it does, you notice that, again, we have areas that are not covered in snow. Part of it is this asphalt. And part of that is the surface temperature of these areas. And that's something that we can see when we have snow cover. If these areas are warm, or if we do something to warm them up, like add salt or something like that, or even plow them, we are removing that snow cover, which might be why that pixel is only reporting 65% snow cover. We have roofs that intercept some of that. And actually, as you can see on the top of this roof here, I'll zoom in. One, it pixelates, right? So again, we've got the same image resolution issue as we do from space, but we can actually see the way that the different temperature of that roof. And that temperature could be because of that internal heating, just like the Earth has some internal heating. Or it could be the way the sun has already illuminated this part of the roof line and maybe caused it to do some melting. But this is the same sort of topography that we see in landscapes and the same sort of melting that we're trying to figure out. Why does this part of the area have no snow while the rest of the area appears to have more snow to it? These are like a really good example of what we're trying to do globally, right? And this is just one direction, one photo. And so this is a little bit of my challenge right now as I'm going through all of the photos and the 12,000 locations that were submitted during that 1 month, and looking at the photos that were submitted to corroborate whether that indication and flag of snow on the ground is correct. So this is image analysis. We can teach a computer to do it, and we're working on that. But I'll just say, there's a lot of things that a computer will not recognize here that I think are really interesting. And I want to note that I can actually see a little bit of the depth of the snow in this particular photo. And part of that is because, a week earlier, we had seen that it was grass. So that kind of gave me a little indication there. But one of the things that you hopefully can also see here is there are some sort of areas in the snow that are a little bit more dense. They're the same color, the same sort of pattern. And then we have other areas that are a little bit more blocky. And because I sort of have looked at a lot of snow, I know what we're seeing here is grass popping up out of that. We have an image resolution issue again, so it's not very clear. This will confuse the computer. But as a human, I've got eyes. I also have years of experience of walking through places like this. And so I can, especially with that past photo, I can start to see and understand how the land cover of one moment in time can help me to understand actually the depth of this snow at this next moment in time. And one of the things that I start to notice too is underneath the trees, I start to see some dark areas and some bright areas. Again, all of that indicates to me that this snow isn't very deep, which also is corroborated when we go back to our submission and look a week later. We can look at the same view, and we can see evidence. Yeah, there was snow there, but we can see how a lot of it has gone away. It's changed. And one of the things that is really useful with this sort of series like this is, why does this snow persist in these locations? And I'll tell you, this was part of our investigations. If you look at it, part of it you can actually see is a snow pile, right? And so it's not a good representation of the rest of our area, because people actually moved this and made it deeper, denser. But this is the kind of thing that happens naturally out on the landscape. And this is one of those features that sometimes will happen for 1 year if it gets really, a lot of snow, and it just persists on the landscape. In land cover world, for us in Globe, this is known as a perennial snowfield if it was to stay there for 11 months. And so to know that, we would have to have observations for 11 months to be able to label this as something that stays around perennially like that. Otherwise, we would flip that around and say we have annual snow cover in this location. And that, again, is a characteristic of this particular pixel, this location, and even maybe why we're seeing the type of tree leaves and shapes that we are. But all of these are just little indications that come through that a photo like this remote sensing helps us to understand, again, what we were seeing when we are looking at satellite data like this. In this case, it's black, right? And so, you know, we have to use our other data to make sense out of what we're seeing. And so, you know, I'm going to just like flip through and go through and see a little bit more of what's available there. We'll just go out a little bit. But this is my first place that I'm starting to look at snow cover layers and data that is out there on a daily basis that might coincide with my photos or with my measurements that are out there. Now, one of the things, again, that you can start to do is you see down here, we actually have put together, or scientists have put together, an 8-day composite. So this is really important because, as you saw, there were some days that were cloudy. And so one of the strategies we use to get around that cloudiness is to look at a window of time. And in this case, I'm going to turn on this 8-day option. And what that allows me to do is I'm going to turn off the other two that are daily. And what you'll notice here is we have more of a legend. And what you'll see is that we are looking at whether the area had snow at any point during that 8-day, or is it an area where we don't have any information and we fill it so that we have some data there. There's another value where if it's really, really bright all the time during that 8-day, that can actually make your measurement wrong, or saturated is another word. You also have lake and snow, lake ice, which is different than what's on the land. Cloud cover during that 8 days is a really important one. And I like this one because, you know, some areas are just cloudy for that whole entire date range. And so, again, this is where our ground measurements are most valuable. You can see that there's another ocean, or there's an ocean value. Importantly, there's this no snow value. And this really becomes what we're sort of looking at, right, is the difference between no snow, the green areas, and the areas that have snow. And we have a couple others, missing data. And so this, again, is really important when we start looking at a location. I'm going to zoom in on where we were just looking at this point. And as we zoom in, you'll see that there is a label, and one of our sensors is telling us one thing, and another one of our sensors is telling us another. So I love this because we, again, have to try to use our brains to figure out, why is this happening? Why does one of our sensors tell us, oh, there's no snow here during this 8 days, but this other one tells us that there is snow? I love this because it really is there might be a good reason. In this case, maybe there's the difference is afternoon observations versus morning observations. Just like what Brian was showing us, that timing of during the day, or that observation, maybe the snow actually melted during that time, in between your 11 a.m. measurement and your 2 p.m. measurement, which is what these are around here. But this discrepancy right there is what scientists are struggling to understand themselves. And especially when you have like such a large difference between one day and another, one time and another time. But that, it could be true. And we need to spend that time going in and investigating our measurements in relation to especially these summary ones, these 8-day ones, and the monthly ones that we're trying to use to avoid those clouds. As Valerie was highlighting earlier, people really are focused on those clouds. That's their job, and that's great. But then there's some of us who really don't want those clouds, and we need to focus on those cloud-free days or figuring out how to work around the clouds. And that really, like I said, is part of our challenge here with these particular snow layers. I want to go in and I want to end here this little investigation with showing a new layer that is coming for us. And part of this gets at that resolution piece that I keep talking about. Most of our snow products are at a 250 meter or 500 meter or 1 kilometer pixel scale. They're very, very coarse. And part of that is just because we care about getting back there on a daily basis, because like we were seeing, snow can change so fast that we really need that time piece to be the focus of our investigations or our measurements. However, we also lose that ability of to see the variability. And so with some new updates, Landsat 8 and 9, which is a 2 different satellites that have the same sensor, the OLI on there, the operational land imager, but it has the ability, just like most of our satellites, to recognize snow. And so one of the layers that should allow us to zoom in and get a little bit more detail for what we were just looking at is this snow index. And we have another one that comes from a different series of satellites, but again, between these two, we hopefully can get that revisit time and see the location in a little bit better resolution. And so again, you might not have it on the day that you're after. So if you turn off those different layers, one of the things that you might need to do is walk through and just go back in time and see when you get this little eye that pops up. And, you know, in this case, I'm not getting, I could zoom out and find out where that is. But here, you know, we just keep going back and we hopefully at some point find matching data. If you don't find matching data, that is okay. That is to be expected. That is one of our challenges, actually. And it also means that you can't use the methods or ideas that other people are using in their locations. And so, you know, that becomes one of our challenges. And I'm going to just zoom out and see where the heck are we getting imagery on these days, right? And we can see I'm letting that go. But this demonstrates kind of our challenge of trying to measure snow from space. Is you see the areas that are cloud-free are the areas that have these little boxes going through. And then the black areas are areas that didn't get a measurement that day with this particular satellite and resolution. So let's zoom back into this Indiana area, just because we're supposed to have some information or some data there, right? And so eventually zoom in and we might get some data. But this really is the first thing that all of us scientists do, is go through and see, are there clouds in the way? Can we see what we're after? And does it align with what we're actually measuring on the ground? And so I'm not getting anything, except for these blocks showing up at this particular location. So this is the sort of the stage that I'm at in terms of my investigation of what data was submitted, what actually came in, and any of our other patterns that we might see in our global distribution of snow cover. Again, I'll go back that we have a hypothesis here of what we should be seeing at these locations. And so, this is exactly what everybody can do themselves to go through and try to find coincident satellite data. We've highlighted some other tools in the past. And so I want to share this particular resource because it's exactly what we were doing. And again, we're not novel. This was written in the year 2017. And so the methods are exactly the same, but the data might have updated between now and then. We might have had more measurements. But this connection between snow cover and surface temperature, again, is a big focus of our research and trying to understand why do we have the surface temperature at the time that we do, measuring at what we do. And this was something that I did and made some videos of, and you can find on our Snow Views video page. But I want to ask. Because I want to get a little interaction here a little bit. But what do people think here is the surface temperature of snow? What do you think you would be measuring? What do you think? What numbers might you get at something like that? So while you are working on that, I want to stress that we have 2 videos here that can help you with this. And I won't play them for you right now, but you can go to our Snow Views webinar and you'll see me use the Stella instrument here to actually make some surface temperature measurements of snow and also pavement. And here in my final video, I made a snow measurement in at about 10,000 feet elevation in the middle of the state of Colorado at this particular latitude, longitude, 38 degrees and minus 106. And what that showed is that surface temperature of snow was 0 degrees Celsius. And that makes a lot of sense. This is something that may not be obvious, but snow is a really good insulator and tends to be the same temperature, especially as it changes over a season. It tends to go towards that 0 degree level. And so that might be a number that you come up with when you're out there using the GLOBE protocol on measuring surface temperatures. And remember, snow is a surface, and it's not always exactly what you see it as at that moment. But this is, again, this nice this connection that we're trying to make. I want to highlight that we already have some numbers coming in from some scientists. We highlighted this group, the Rutgers University Global Snow Laboratory, which uses NASA and NOAA satellite data to give us trends. And they're showing that we're a little bit below normal of our surface snow extent, but it's not as bad as it was in 2024. What that means and where that is occurring, I think, is the important thing. So, continue to make your Globe Observer observations where you are recording that surface conditions, snow, yes or no. not always a straightforward answer, as we saw there. But do your best there to answer whether you're seeing these conditions and whether you're seeing that snow extent. And especially as you start going into maybe green up, whether that's grass green up or shrub green up or tree green up, that's one of those things that, again, we're trying to sort of watch as we go from maybe a white landscape to a different color, a green landscape, if you will, for green up, right? So we'll be looking into this much more and trying to understand all of the data that was submitted. Like I said, about 12,000 points were submitted during that 1 month through the 3 different Globe Observer protocols. So you gave us a lot of data for us to go through, but again, start looking at it yourself and seeing what's there. And I was really impressed with this particular submitter who has provided us with now 6 weeks of observations. We don't know exactly the timing because there's a week difference here between them. That happens, as you saw. We have ways of getting around that, but it at least helps us to know that there was this event, snow event in this case, that went through. And I want to stress that one of the things that we can do with this, and we want to start doing, is when the trees start greening up, this is when we might see damage to some of our trees. They may not, all the tree branches may not have survived. And so where the green up is occurring is another one of those features that help us to tell how long was the snow on the ground? Was there damage to the trees that might have been something that we didn't anticipate? Or maybe we did anticipate it. Again, that's one of those things that different scientists are working on different hypotheses and different predictions. So, get out there and as you're making those tree measurements, add in that land cover because with the shape of that tree may not be the same as it was last year when you did that. And that's one of those things that winter tends to bring changes to our trees in ways that aren't always appreciated until you go out there and when it's nice and you notice that the tree branches aren't quite as illustrious and don't provide the shade that they used to. So thank you all for being part of our Globe Observer, our Snow View Challenge. Again, I want to stress that as we are looking at the submissions, I'm going to zoom out here, so hang on. One of our big things is we don't want to overwhelm everybody, right? Snow is a fun thing, but it's also not the only thing that is happening out there. So there is this green up piece that's happening, at least here in the Northern Hemisphere across the United States, where many of these places might be changing colors. And I want to stress that one of the things that we're really hoping to see is the further north and the further south areas, we want to really know when is that timing of that last snow or the timing of that first snow when it comes. And that is something, especially down here in the Southern Hemisphere, we're hoping to be able to go back to ideally around August. So, we're going to be ending our 7th year of our Trees Around the Globe student research campaign around that time. And so we hopefully will be able to capture that green down and the snow cover that might be coming to our friends in the Southern Hemisphere who didn't get to see or notice all of these fun things that were happening in the northern part of the globe at this point in time. And so that again is one of these wonderful things that a global community can help us to see these patterns that I didn't get to experience. Brian got to experience a few things. John Moore got to experience a few. And many of us, we got a lot of good contributions from the Northern Hemisphere that really reflect snow cover. But again, one of our things that we hope to see and that we focus on here within our Globe community is this Earth as a system. So take the opportunity to, as you're planning your summer, think about areas that might be snow covered right now and how they might look when you go there in August, or when we get together, in Washington, D.C. area, closer to where Brian and John Moore were describing their conditions. What are we going to experience in a couple months? And how does that reflect with what we have observed during this snow view time period? So thanks again for joining us for a little bit of a review here of what we did with our snow views. And I'm really excited to see what the students who were working between Texas and Argentina are able to illuminate. Because as you saw when we were looking at that map, those were two areas that both really didn't experience any snow cover this year. And so what might be the similarities or might be the differences in those areas that both were experiencing warm conditions, right? They didn't experience any precipitation or any air temperatures that might have been cold enough to actually create that. So a lot of fun indicators are there, and we'll be hopefully sorting through these photos and other things like that. But we look forward to any suggestions or ideas about what people saw this winter themselves as we go through and are reflecting on February 2025.
All right, thank you, Peter. Does anybody have any questions for Peter? I know he asked a few during his presentation, but anybody have any questions? You can unmute or pop it in the chat. I always like to say, Peter, you've done such an amazing job of explaining that no questions are even needed.
Yeah, exactly. I mean, because a lot of it is go out and explore this data, right? I think that is our big task right here is we presented some places. I have those places that I go to, but it really takes on meaning when you start to explore the data, the open altimetry data, the snow cover data on worldview. All of these tools that we've provided to you really make more sense when you start exploring it in your location, because you have that background, you have that experience, and that's something that keeps coming through to us is we all have this experience within us, and the satellite data helps us to understand that in both ways. And so I do hope that some of this data that I tried to show you today that wasn't there is in beta and is coming. And so again, there's a lot of, I think, opportunities for us to keep building instruments, to keep looking at remote sensing of this really complex topic of snow, because it is something that really requires a long database like this to hold our winters, right? And as well as a way that we can keep this going from one generation to another, because I've heard that winters aren't the same as they used to be for a long time. So we got to experience what we got to experience, and I hope that everybody enjoyed the real-time experiment that Brian brought to us, as well as John Moore. And again, I'm really excited to see what continues to happen as trees start to wake up and shake off some of that snow that has accumulated around them.
All right, thank you, Peter. All right, in the last couple minutes, I'm going to just want to share last couple things here. As I mentioned, I'm pretty sure you probably see my screen here, but here is, and I'm not going to go through this, but this is just a link and shows you where the latest blog is that I mentioned earlier. Globe Observer Trees Just Got Even Better, where it's talking about the added tree genus and species identification on the app. Also, I mentioned about the March. What's happening right now is with Dr. Kevin Chakowski, University of Toledo, Urban Heat Island Effect Surface Temperature Intensive Observation Period. So you can go ahead. I put all the links in the chat already while Peter was talking, and you can check this out. This is the page about the IOP, the Surface Temperature IOP. But then also there is a page that you can go to as well that is for students. So it's goes a little more into the science, how to collect the data, why you're collecting the data, and some examples of projects from the past, and a little video about what exactly Dr. Chakowski is looking for. And then finally, I want to bring your attention to this. This link is also in the chat. And Matt Nyman was here last campaign webinar last month talking about he's part of the evaluation team at Oregon State University as part of the NESIC program, which this campaign is listed under and funded under. I want you to take a look, and if you could, complete this short survey, if you haven't already, about the Trees Around the Globe Student Research Campaign. And once again, all these links are in the chat for you. And stay tuned for updates in the next couple of days about the next webinar that I mentioned earlier, then also the recording of this webinar as well. So thank you all so much. Thank you to Peder Nelson and Peter Falcon on the campaign team, and all of you who joined us from across the globe community. So thank you, and make sure you share this with your colleagues to watch the recording once I get that information out to you in a few days, probably by tomorrow. That's all depends upon how long it takes Zoom to get it to me. So thank you all so much. And, with all this snow talk, stay warm the best you can. So thank you all so much.